morning, children. We continue the topic definite integral. In the last class, we had a discussion about how the formulas are derived. So I have listed out the formula for integration, the direct formulas. I just recapitulate again. Integral. That times we have just taken the formula like that, d by dx of so and so function. The integral of that one is like this. So today now I am directly going to write the formula. Integral of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1 plus c. Then second one is integral of e raised to x dx is equal to e raised to x plus c. And third one, integral of log mod x is equal to 1 by log x derivative is 1 by x. So integral of 1 by x dx is equal to log mod x plus c. Here you can see that this is when n is not equal to minus 1, because n is equal to minus 1 becomes 1 by x. So that is why this is having a separate formula. 1 by x dx is equal to log mod x plus c, and then integral of 1 by 2 root x. I will write that is also formula, because we can get this also from here. 1 by 2 root x is equal to root x, because root x derivative is 1 by 2 root x. Then this also I write as a integral of 1 dx. It is x plus then the trigonometry functions. Integral of sin x is equal to minus cos x. And see the other one. Integral of cos x dx is equal to sin x plus c. Then integral of secant square x is equal to tan x, because tan x derivative is secant square x. Then integral of sec x tan x. Derivative of sec x is sec x tan x. So integral of sec x tan x is equal to sec x plus c. Integral of cosec x cot x. You know that the derivative of cosec x is minus cosec x cot x. So cosec x cot x integral is minus cosec x. Then integral of cosecant square x. You know that the derivative of cot x is minus cosecant square x. So integral of cosecant square x is minus cot x plus c. Then trigonometric functions, that is integral of 1 by root of 1 minus x square. 1 by root of 1 minus x square dx. Derivative of sin inverse x is 1 by root of 1 minus x square. So this is sin inverse x plus c. Or derivative of cot inverse x is minus 1 by root of 1 minus x square. So you can have this answer 2, that is cot inverse x plus c. Sorry, cos inverse x plus c. Then integral of 1 by 1 plus x square dx. You know that derivative of tan inverse x is 1 by 1 plus x square. Therefore, integral of 1 by 1 plus x square is tan inverse x plus c. Also, you know that the derivative of cot inverse x is minus 1 by 1 plus x square. So, this can be 2 as 4 minus cot inverse x plus c. Integral of 1 by x in root of x square minus 1. We know that the derivative of secant inverse x is 1 by x in root of x square minus 1. So this integral is secant inverse x plus c in a similar way, or it is minus cosecant inverse x plus c. These are the formulas which you have studied in the last class. So we will be using this formula. It is not necessary that in every case we will be getting directly the question based on this one. Then things will be very easy. If the question directly give like that, if you by heart this formula, things will be over. But there are some functions which is maybe given function of function type. In the differentiation we have a function of function, that is chain rule. But unfortunately here when function of function comes, the things are not so easy as we compare with the differentiation. That is why the integration process is little bit tougher than the differentiation process. Okay, now let us see that how it is the function of function comes, how we can integrate that one. Here you see, I want to find the integral of sine 2x. So normally we have a formula for integral of sin x dx. Formula is that it is minus cos x plus c. So we have to check whether we can directly write integral of sin 2x dx is equal to minus cos 2x dx. Can we write like that? It is answer is no. Answer is no. We just remember the definition of the integration. We have to here integral of sin 2x dx is that we have to find out a function whose derivative is this one. Now let us think about a function cos 2x. What is the derivative of this one, cos 2x? We know the derivative of cos 2x is minus sin 2x into 2. This is the derivative. So you cannot write directly this sin to integral sin 2x as cos 2x, because the cos 2x derivative is minus 2 sin 2x. So if you want to get the sin 2x, then you should have our formula, our thing should be minus 1 by 2 cos 2x. If you take the derivative of minus 1 by 2 cos 2x, when you take minus 1 by 2 is a constant, derivative of cos 2x is minus sin 2x into 2. So that these 2 cancels and minus gives sin 2x will get. So what is the function actually? This is the function whose derivative is coming as sin 2x. So normally the answer should be cos 2x by minus cos 2x by 2. Minus cos 2x by 2 plus. Yes, this is one, you keep it as like this. Now listen to another. Let me see about the cos 5x. I want to find out the integral of cos 5x. We have to think about a function which gives its derivative as cos 5x. We know that the derivative of sin 5x. What is the derivative of sin 5x? D by dx of sin 5x. So d by dx of sin 5x is cos 5x into 5. So if you want to get exactly cos 5x, then there should be a 1 by 5 here, so that you will get 1 by 5, so that 5 cancels, and then you get the cos 5x as the answer. So the answer for this one is sin 5x by 5 plus c. Now take the third example. Say integral of e raised to 3x. Suppose I want to find it. You know that d by dx of e raised to 3x is equal to e raised to 3x into 3 is the derivative. So if you want to get a function whose derivative is exactly e raised to 3x, then there should be a by 3 here, so that this 3 cancels, you will get exactly e raised to proceeding in this process, which is the function who will give like this. So we should have some shortcut method to come to the answer directly. When the in place of x, something else comes. So now here, in place of x, here 2x is. So we will be applying the formula of sine, integral formula of sine. Integral formula of sine is minus cos. So minus cos 2x as it is will write, divided by the derivative of this expression. Derivative of this expression is 2. See here also cos 5x. We know the integral formula of cos x is sin x plus c. So integral of cos 5x, we write sin 5x and the derivative of this expression, that is 5. E raised to 3x. We know that the derivative integral of e raised to x is e raised to x itself. So integral of e raised to 3x is e raised to 3x by 3. This 3 is the derivative of this expression. So when some function comes, this is. But here we should be very careful. This cannot be applied for all the cases. For example, if I want to find out the integral of sine 2x square, I cannot do it because this is 2x square. Here you cannot write it as a minus cos 2x square divided by derivative of 2x square is 4x. It is wrong. That is wrong. You cannot do it. Because why we cannot do it? You just think about, you take the derivative of this expression and check whether it is coming like this. It will not come. The same way if it is e raised to 3x square plus 4. You cannot write the answer as e raised to 3x square plus 4 divided by the derivative of this expression, that is 6x. That is also wrong. It is also wrong. Why? Because just check it, when you differentiate this one, you should get this answer. You will not get it. So these cases it is applicable only when in place of x a linear function is there. Here also is linear. This is also linear. In place of x, when a linear function comes, it can be done. So in general, we write like that. Suppose if I want to find out the derivative of sine, is integral of sine ax plus b. It is a general form of a linear one. Sine ax plus b is, sine integral is minus cos. So cos ax plus b divided by this expression's derivative. This expression's derivative, that is a. This is the general rule for finding out the integral. When function of function comes, in that case it should be a linear one. The same way, if we want to find out the log 1 by ax plus b, what you know that integral of 1 by x is log x. So 1 by x plus b, it will be log mod x plus b divided by the derivative of this expression. And similarly, suppose if you want to find out this one as integral of cos ax plus b. You remember this one, this should be a linear one. In place of x, a linear function should come. So cos integral is sine. So sine ax plus b divided by the derivative of this expression. So remember, make a comparison. In the case of differentiation, chain rule, whatever comes in place of x, we multiply. In the case of integration, whatever in place of x comes, we divide its derivative. In the case of differentiation, chain rule is multiplying by the derivative under the inside the bracket. In the case of integration, the derivative inside the bracket expression is to be divided. And in the case of the integration, there is one more restriction, that this can be done only when inside the expression there is a linear one. Now I just see the another example. See, suppose if I want to find out 2x plus 3 whole raised to 5. I want to find out these expressions. Integration. So we know that integral of x raised to n is x raised to n plus 1 by n plus 1. So here it is 2 2x plus 5 raised to n plus 1 divided by n plus 1, and you have in place of x a linear expression. A linear expression. What is the derivative of this linear expression? 2x plus 3 derivative is 2. So this 2 is to be done here. This is the answer. Now suppose if I want to find the integral of e raised to 5x plus 3. You know that integral of e raised to x is e raised to x itself. So here we write e raised to 5x plus 3. In place of x you have a linear expression. Its derivative is 5. That is to be divided. So this is the way we find out the integration. I will share some of the questions in the both Google Classroom as well as in the WhatsApp. Please submit in the Google Classroom itself. Thank you.